Hello cloud engineers and welcome to this module in which we will discuss about the Redshift cluster setup, delete and update. In this module of the course we will discuss how to create a new Redshift cluster and naming standards to be followed for a Redshift cluster, selecting the number of nodes of the Redshift cluster, adding IAM role to the Redshift cluster, making the Redshift cluster publicly accessible, encryption of data in Redshift, backup and its importance, how to review the information displayed on the console after the cluster is created, how to resize, modify, pause or delete a cluster, snapshot creation when deleting a cluster on demand, deferring maintenance on a Redshift cluster, modifying public accessibility settings, and create a cluster from a snapshot. And finally, we will summarize everything that we have discussed. So without spending any further time, let's go on to the Redshift console. So now as you can see, I'm in the AWS management console, and over here you see I'm in the top right, I'm in the Northern Virginia region. And what I'm going to be doing is that I'm going to be going here and I'm going to look for Redshift because that is the service that I need. I can see Amazon Redshift here. I will click that, and what should happen is that you should be able to see the screen, and in this screen you have what is known as a create cluster option. Do spend some time trying to look over the benefits, features and all that, the use cases. You can take a look at all that when you get a chance. If you're relatively new to data warehousing on Amazon Redshift, you can also watch this video which will tell you what it can do. Now before you create a cluster, you have the option of looking at the on-demand pricing, which typically runs at 25 cents per hour multiplied by the number of nodes you have. Also reserved instance pricing. Reserved instances are basically instances that you reserve for a time period of 1 year to 3 years, and you get discounts on them because you have reserved them for a longer period of time, as against on-demand pricing. Reserved instances makes a lot of sense for organizations or companies that are committed to using Redshift for their data warehousing needs. It does not make sense for us, so we will always be on on-demand pricing because we need to be able to create Redshift clusters and terminate them as needed. So what I'm going to do now is that I'm going to hit the create cluster button, and now that you have hit the create cluster button, what you can see is that there is a default cluster name over here, which as you can see is all in lowercase, separated by what is known as the hyphen. Now a lot of organizations have naming standards, and these naming standards require that the database names be uppercase or lowercase or require underscore. But what we have to remember here is that these things are not allowed. Uppercase and underscores are not allowed in what is known as the cluster identifier, which is essentially the name of the cluster. So in order to prove that, what we are going to do is that for now we are going to do an underscore instead of a hyphen, and we will check if Redshift will allow us to create that cluster. Now over here there is an option for a free trial and production. So I don't have a free trial available now for me, so I'm going to go with the production version. Over here I have to choose the size of the cluster. So we did discuss node types in one of our previous classes, so you can actually go here and decide what kind of node you want. I am going to go for DC to large, and I'm going to go for 2 nodes. I can use this slider to change the number of nodes I want, but I think 2 nodes are good for me. I could even do 1 node if I want, but I'm going to go with 2 nodes. If you are in your organization and you're not sure how much what type of node you need to use, you can use the sizing spreadsheet that we discussed about, or you could also go to this calculator over here, which is the help me choose calculator, and you can put in some information out here. So I'm going to say that I have 200 GB of data. My data is time based. That means like a retail store where data is coming on a regular basis. Now since it's a data warehouse, I'm going to keep it for at least 10 years, so 120 months. How frequently do you use it? 36 months. 36 months of data is what is most relevant for me. and based on this input that I gave, which could be different in your organization, it is going to tell you its recommended what is known as a configuration. It is also going to give you the approximate cost for a year, okay, and the storage capacity. You can always download this in CVS format, and the reason why you would want to do that is so that you can send it to your manager or whoever is responsible for costing to show them how you came up to that. Reserved instances. So reserved instances basically means that you're entering into a contract where you agree that you will what is known as agree to use this instance for 1 year or 3 years, and the longer you commit to using it, the greater the discount. As I just told you, it makes more sense for organizations that are committed to using Redshift for several years. So based on DC2 large and the number of nodes 2, this is what it is giving me. It is giving me a capacity of 320 GB and estimated cost of $360 per month. Now we don't need to be what is known as shocked by this amount, because we are basically in on-demand pricing, which means we will be spending 25 cents per node per hour, and I'm using 2 nodes, so that will cost me 50 cents. So generally, as soon as you finish using your node, so you may use it for a couple of hours a day, it is going to only cost you a couple of dollars, because we are going to shut down our instance as soon as we are finished. Okay, so then we go down, we have a database name that you can give over here, which in this case is dev. You could give QA, prod, or anything else that makes sense to you. There is a default port number that we have, which you can leave as it is. It also says that the database name is optional. What that basically means is that you can create the cluster, and then you can later come in and then create the database as a separate procedure. Now that wouldn't make a lot of sense, because you anyways have to create a database in order to be able to use the Redshift cluster effectively. So the best thing to do is to just go ahead and create a database as soon as the cluster is being created. Over here you have what is known as the master username, which they have provided by default. And what you can do here is that you can create a master uh, password. Now it is important to remember this password, because this is like the super user or the root user, depending on what terminology you like to use. Please remember it, please save it. It is going to be required later. Then we go into cluster permissions, and though this is optional, this is very critical, and let's try to understand what this is. Now when you create a database or a Redshift cluster, uh, Redshift can operate in isolation, but Redshift may also need to what is known as integrate with other AWS services. Now, as you can see here, let us say that Redshift needs to talk to an AWS service like S3. By default, Redshift is not going to have the ability to what is known as talk to S3. Or if Redshift wants to talk to DynamoDB, Redshift is not going to have the ability to talk to DynamoDB unless you, as the Redshift developer or architect or modeler, decide to provide some privilege to the Redshift cluster with the help of an IAM role. Now, if you come to this drop down, you will now see that any role that you have created or any role that is already available by default will show up here. Now, AWS has already provided what is known as a service role for Redshift, which has a set of privileges that you can potentially use. But what we are going to do is that we are going to create a role now that allows this Redshift cluster that we are creating to be able to access S3, to read data from S3, and to write data from S3, and give it full privileges on S3. And the reason why it would make sense to do that is because S3 and Redshift talk to each other very frequently, as we will see as we move forward in this course. And for that reason, it is important that we create a role which will allow Redshift to talk to S3, read data from S3, write to S3, and perform all those activities. So now let's go to the AWS management console, and what we are going to do is that we are going to go to IAM, and once we come into IAM, our goal is to create roles, so we will select roles here. And once we select roles, we are going to do create role. Now what we have to do is that we have to look for Redshift that we can find here, and here it gives you three options: Redshift, Redshift customizable, and Redshift scheduler. Now scheduler is basically something in which you want to schedule a particular task for future. So definitely we don't need scheduler right now. Okay, we might take a look at it later. Now the options we have is Redshift and Redshift customizable. So let's try going with Redshift and see what happens. We do next, and over here we see what is known as Amazon Redshift service linked role, which comes by default. I'm not able to select anything else. I come here and I'm actually going to look at this privileges that have been listed here, and as you can see, all the privileges related here are related to EC2, and because they are related to EC2, it would not make any sense for me to use this role. So I'm going to cancel out. Okay, so what I actually need is a different role which will help me what is known as get access to my Redshift instance or my Redshift cluster to S3. So I'm going to try and use Redshift customizable. I'm going to hit next, and I'm going to look for S3 full access. Okay, so I want to give my Redshift cluster full access to S3. So what I'm going to do is that I'm going to select this privilege, S3 full access. I come here, I see action is S3 and resources star. Basically what that means is that Redshift is allowed to perform any action on S3. Then I'm going to go to next tags, and then I'm going to do role description. Okay, so I'm going to select role allows Redshift to access S3 data for loading and unloading. I do next review. I'm going to write role Redshift S3 admin. Okay, so then I'm going to do create role, and what I'm going to do is that I'm going to check. It says that the role has been created, and I'm going to check if the role is there. So as you can see here, there is a role that has shown up here. I'm going to go back over here. I'm going to do a refresh, and then I'm going to see. So now you see the role that I recently created. I can find it here, and I do add IAM role. So let's try and discuss what we just did. I created a role that has admin access on S3, and I assigned that role to the Redshift cluster that I just created. Now it is quite possible that your Redshift cluster might need access to DynamoDB. So what you should do in that event is that you should what is known as create a role here for DynamoDB, and then attach that role. Once you do that, a role will be available here, and then you basically attach that role to the cluster. Now I'm going to attach another role. This is the default role that already exists, which is the AWS service role for Redshift. You're allowed to associate up to 10 roles. Okay, you generally won't need more than that, but in the event that you need more than that, what you can actually do is that in a given role you can combine more than one privilege. So you could do S3 and DynamoDB privilege inside one role instead of creating multiple roles. Now generally, as the best practice, that is not recommended, because what happens is that if you need to remove some privilege like the DynamoDB privilege, and if all the privileges are combined into one role, you are actually going to have to go in and edit that role, which will increase the chances of something going wrong. It would just be easier if every privilege had its own role, and I could just hit the remove button and remove the what is known as and remove the privilege provided. Now let's move forward and look at additional configurations. Here by default it says use defaults, but that will not work for us. We will try to look through all the options that are given. Network and security, we are going to use default VPC. Security groups default, cluster subnet group default, availability zone, I don't have any preference, but if you have any particular preference you can select. It would not matter right now, but in your organization it might matter, so you want to take a look at that. Enhanced VPC routing, we don't need that. Publicly accessible, no and yes. Now this is important for us. Now, typically what is going to happen is that the cluster that we are creating is inside a data center, and we are trying to access the Redshift cluster from our home or from our, through our via internet. Now, since we are trying to access this publicly, it's important that you select yes here, because if you select no, what is going to happen is that you are not going to be able to what is known as be able to connect to the Redshift cluster via the internet. So in order for us to be able to connect to the Redshift cluster and be able to create tables and to be able to run queries, it is important that we select yes here. The next option here is elastic IP address, and as most of you would know, elastic IP address is essentially a static IP address that you can choose to give uh, your Redshift cluster. In my particular case, I don't have any elastic IP addresses available here, but in my particular case, it does not also make sense to assign an elastic IP address. Now, in what case would it make sense to assign an elastic IP address or a static IP address? Now, that would make sense in a case of a company where external data vendors are coming and trying to access that Redshift database over the internet, and you cannot afford your IP address to change. That would be a use case where you want an elastic IP address or a static IP address to be assigned. The other thing to remember is that every time I restart my Redshift cluster, if I don't have a static IP address, there is a possibility that my IP address will change. So if you have a use case where your IP address has to remain static, in that case, it's important that you go to the console, generate an elastic IP address, and once you generate it, it will be available here, and you can attach the elastic IP address to this cluster. It will not cost you any money to create an elastic IP address, so that is something that you can do. But if you create an elastic IP address and don't use it, it is going to cost you money. So you want to be careful on how you use your elastic IP address. For now, I'm not going to be doing that. The next over here is parameter groups, and over here, as you can see, I have three parameter groups. This is the default parameter group, which is Redshift 1.0, and I have created two other parameter groups. Now let's try and understand what parameter groups are. So the easiest way to understand this is that let us say you are in Europe, and in Europe the date format is in DD MONYY, which is day, month and year. And if you are in the US, the date format is in MMDD format, which is month, day and year. So what the parameter file in Redshift contains is certain default what is known as parameters that the database uses when it starts up. So if you want to change or override the default behavior, as I have done in the case with using Redshift parameter 2 and Redshift WLM manual, what we can do is that we can actually create a new parameter file and apply that to the in the database configurations option. Now, when you are creating this for the first time, you are not going to see this option. So what I would recommend is that you simply use the default Redshift. We will see how parameter groups are created later in the course. So don't worry about it too much. Next, we are going to see about encryption. In encryption, we have three options. We have disabled, we have use AWS KMS, and use of HSM. Now, some organizations have a requirement that their data have to be encrypted, and so what you could do is that you could take the easy option wherein you select AWS Key Management Service, and what you can do is that you can use the default Redshift key. In this process, what happens is that Redshift manages everything. They manage the key, they manage the service. You still have encrypted data, you don't have to worry about anything. However, there may be cases where organization policy require that the organization use keys that the organization has generated. If you do generate a KMS key, that key will be available here, and you can select that. There may be cases where you are required to use a hardware security module, which is essentially a device which will generate keys which can be used. At this time, it is not very important to understand at a very deep level, but what you need to understand is that a hardware security module is essentially a device which allows the customer, maybe let us say a bank like Bank of America or Chase Bank or Wells Fargo Bank, to generate their own keys, right? And these keys are then used to encrypt the data on Redshift. So they are going to what is known as use keys that are outside the management or control of AWS. But for our need, we are going to use Amazon Web Service KMS, and we are going to use the default key. Okay, so then let's go to maintenance. Now, as you can see here, there is a maintenance window. So if you are working in databases, you'll see that every now and then you will get an email from your database administrator, and the administrator will say that the database is down from this time to this time for maintenance. Now you are on a cloud database, and Redshift requires some time to apply maintenance. So essentially what you will do is that you will select a time period over here that will allow Redshift to shut down your cluster and apply maintenance or patches or upgrades or anything of that kind. So this is in local time, and the UTC time is provided here. So this is Sunday midnight. Now I might have jobs running at Sunday midnight, so what I'm going to do is that I'm going to set this for 1 o'clock on Sunday, because I know that my nightly jobs will be over and there is going to be no work from 1 o'clock onwards. And generally this time window is only for 30 minutes. So there is not any major downtime, or it's not down for a very long time. The next what we have to look is maintenance track. Now what is maintenance track? Let's try to understand that. We have current, we have trailing, and we have preview. What happens is that Redshift is continuously enhancing its software, and they want to apply new versions of their software or their cluster versions, so that if you as a customer can get those benefits. So let us say that in the latest release of Redshift, Redshift has decided to introduce a new piece of functionality, and for the sake of our discussion, let's call it materialized views. Now, if you are on current, what is going to happen is that uh, as soon as that software or that cluster version is approved, what will happen is that during your maintenance window, that functionality will be applied to your Redshift cluster, and you will be able to now create materialized views inside Redshift. However, if you use trailing, what is going to happen is that you're always going to be one version behind. So materialized views are available as the most current version. If you are on trailing, you will not have that. However, when the version moves forward, right, and in the subsequent version, let us say stored procedures are installed, are created for argument's sake, what is going to happen is that because you're trailing, you will now get what is known as the materialized views. So basically with trailing, what we are saying is that you're always one version below the current version. So the question is that why would someone use a trailing version when they could simply use the current version? So some organizations are very conservative, and they really don't want the latest and greatest applied to their database, because they are afraid that something will go wrong and their database loads will get affected. So they always want some other organizations to be the guinea pig for the current. Essentially, other organizations will use current. If there are any issues that they face, they will report that to Redshift, to Amazon, and then they will fix all those problems. And once all those problems are fixed, only then they want to upgrade to the latest and greatest version. Organizations sometimes want to use current because they are growing extremely fast and they need that functionality like materialized views, stored procedures, so they are willing to take the risk. Finally, with preview basically means is that even before the features or the cluster version is productionized, you can actually gain access to it, And the reason why Amazon would want you to gain access with it is primarily for testing. So your organization will work as a test bed for Redshift to ensure that the software is working properly before it goes to current. A lot of organizations do this, especially startups and all that, because they need stuff or functionality that is not yet available, and Redshift is about to release. Okay, next is monitoring. I'm not going to create any alarms here. Okay, you can create one if you want. And over here we come to what is known as backup. So as you know, your DBAs backup your data warehouse every day if you have a database like Oracle or DB2 or SQL Server, and if you're on premises. A snapshot is essentially what is known as a backup. And over here, what you have to do is that you have to provide information on how long you want to retain your backup. So your organization is going to have a policy, and what that policy will say is that okay, the DBA needs to back up the database every day, and he needs to keep the backup for 5 days or 10 days or 20 days or indefinitely. So over here you could come here and you could put in a value here. So let's say that my organization has a policy of 14-day what is known as backup. So I will do 14 days. So it will be a rolling 14-day snapshot, wherein it will take snapshot on day 1, day 2, day 3, all the way to day 14. On day 15, snapshot 1 will be dropped. Day 16, snapshot 2 will be dropped. So you will always have a rolling 14-day snapshot, and we can use these snapshots or these backups in order to what is known as restore the database if something goes wrong. You also have the option of doing indefinite, and it is generally not recommended to do this because these snapshots essentially occupy space, and when your database occupies space, you are going to get charged for that space. So unless you have a very good reason to keep your snapshots permanently, you should not do that. The next thing is configure cross region snapshots. You have disable and you have enable. Now, let us say your organization has a requirement of cross-continent snapshot retention. That means if you are a US company, you are required to save your data in a different continent, primarily to avoid any kind of catastrophic failure like a major flood which will destroy an entire region. You can actually go here and you can select. So I could basically select EU West. Okay, and what does this mean? This means that anytime I create a backup, essentially a snapshot, what it would do is that it would copy that snapshot to a different region, which is EU West. And what this will do is that if you have a major failure which causes all your snapshots to get deleted, which is like extremely rare, what will happen is that your snapshots will be saved in EU West, which will essentially save you from loss of data. Finally, cluster relocation, we are not interested in that, and now we can go and hit create cluster. Okay, so now when I hit create cluster, I got an error called cluster identifier. So when we started off earlier, you remember I had put an underscore here. So what I'm going to do is that I'm going to do this here, and also what I'm going to do here is that it's crying about my password. So let me fix that. Okay, now everything looks good, and I'm going to hit create cluster. Okay, so now the cluster is being created. This is going to take some time, so I'm going to pause the video and I will talk to you as soon as the cluster creation is complete. Okay, so now we are back, and as you can see, the status of the Redshift cluster is now showing as available. It took about 7 minutes for this cluster to get created, and you have to remember that I use 2 nodes with DC2 large. So depending on how many nodes you create and what node type you select, it might vary. But in my particular case, it took about 7 to 9 minutes. With this, we have come to the end of part 1 of this module. I hope to see you in the next module. Thank you.